Hear me now? Any better?
No, okay.
No, okay, cool. So thank you folks very much for coming. Today we have a seminar presentation by Valentin Malykh from North Arc Labs. And Valentin is going to talk about their recent study that they submitted to ICSI. And he will basically tell us about how to search the code better. So first, Valentin, thank you very much for coming. Thank you for being to present. And I'll be conducting the seminar. So Valentin, you have the floor. Thank you.
Yeah, thank you, Mikhail. I will share my screen.
Sure, thanks.
Do you see the screen now?
Yep.
Okay. So now I will start my presentation. First of all, my name is Valentin Malykh. I'm working in Huawei North Arc Lab, and I'm working in the department which is called Speech and Semantics Lab. So I'm actually not coming from the community of software engineering. I'm coming from natural language processing community, and my approaches are from this perspective. So be kind, and if you see that I'm missing something in software engineering, just let it be, because as I said, I'm not from this community. We just getting our expertise to help our colleagues to do some tasks which could be done with our NLP techniques. Okay, so first of all, let me introduce a bit of the field. I need to say that I actually have thought that this could be a really general audience, and I was prepared. I prepared the presentation for more general audience, and hopefully the more knowledgeable colleagues will not fall asleep. So first of all, what is the field I'm trying to talk to you about? This is so-called NLP for code, so natural language processing for code, or more correctly maybe it's called PLP, programming language processing. So instead of the using natural language process, we use programming language process. There was a work maybe a few years back which has been stated and showed. I wouldn't say that they showed it with like crystal clear crystal clarity, but they showed that programming language texts are almost the same as natural language texts. Of course, they look differently, but statistically, they are almost the same. This is not like my main point here, but just why we can apply NLP for such different domain as programming code. So this is on the slide. This thing is OpenAI Codex. This is a chatbot in a way, of course, which is concentrated on the conversation with a person, and conversation not in form like chatbot, maybe you know, like Alexa or some other chatbots. The main idea here is that you as a person write to this chatbot something, and it just do what you tell it. You tell it, for example, draw me I don't know, a plot of some time series or something, and you get this without doing the programming code itself. So this is some kind in philosophical idea of literacy programming or literate programming. Literate programming was proposed, as far as I remember, maybe I'm mistaken, but by Donald Knuth, which is who is actually proposed maybe in someone early 80s or something like this. So this is we just after 40 years are getting close to this. Not like it's already working in a really close domain, but still, this is a really great idea, and I'm really grateful for the two colleagues of in OpenAI to for creating this. Hopefully, someday we can everybody can build this such a software and use it. Okay, so this is like long introduction to more specific details. But firstly, I would like to resemble you for the next great idea. It's called GitHub Copilot. It's been proposed and implemented by Microsoft, I suppose. And this is how it's working. You just feed it with some text, and it produces you the code, which is in some way just written a code for this text as it being description for the function. So it's also a bit narrow domain, but still it's okay. And this is actually close to what I want to tell you. It's more close to the search engine. I'll try to describe to you. But firstly, what I would like to present you, maybe you already know about it, but maybe not. So please have a look. This is a benchmark for the NLP for code, PLP, so-called. For this PLP, which has been proposed by the researchers from Microsoft. And this framework is called Codex Glue. Glue is a famous benchmark for English language in NLP. And Codex Glue is about code and actually a few major languages, for example, document translation, the last row, or row before the last. This is code summarization. This is for, of course, English language mostly. And there are, as you can see, about 10 different tasks which can be actually interpreted differently. And there are tasks like code search and so on. And this is actually a good way to mirror the quality of the models which are meant to be meant to solve some tasks in PLP. And interestingly, what I would like to tell you now is that we actually what I will be presenting is not about the Codex Glue mostly. There will be some Codex Glue parts, but mostly we're talking about some different task, which is the task I will describe you a little bit later, because first of all, we need to understand with the task types, because it's really important to understand what are the tasks we are working with. There are three types of tasks which have been also proposed by colleagues from Microsoft, as far as I remember. Maybe I'm mistaken, but mostly from there. So this is so-called code understanding. Code understanding is when you get some code as a text. This is a really important part, because everything that I'm describing to you is working with a text. That means that code, as we see it, is only text, and this is maybe could be a little bit unusual to you as a software specialist, and you need to understand that from our perspective, the NLP specialists, we are working with only text. We do not know some additional stuff, which are a lot of stuff, of course, in software engineering, but we are working with text. And what we think here, we get the text, maybe it's called code text, but it's could be a text like I don't know, the text I am talking right now. So the text we feed it to some model, for example, CodeBERT, and after CodeBERT, we get the small gray rectangle, which is vector representation of this whole text or whole code. So this is just code representation, and we can use it in different ways. We can use it for classification, maybe for some code search task. For example, this is the task I will be describing. Also, code clone detection, which I also mentioned in some details. But there are a lot of other tasks, for example, which are mostly devoted to generation. And these tasks could be code translation or code repair, or maybe code completion when we are working with generation of the code. So what is important here, I have been showing you the examples which are more easily comprehensible by a person without background. These were the tasks about the generation, and what I am talking about is about the understanding. Okay, so finally,
sorry.
Yeah.
Just a point of order. Do you take questions during the presentation, or would you prefer to have questions after the talk?
This is I actually don't know which is the regulations here. Maybe you have the rules.
I mean, usually we do it during the presentation, but if you like to have the floor uninterrupted, then we can do another way around.
Okay. If you have questions, you could raise your hand. Hopefully, I'll when I get the pause, I'll answer or at least ask for the questions.
All right. Sure. Thanks so much.
Yeah. Thank you. So about the finally about our task. So the business application. We have started with the business application, and actually. Going much further, like skip forward for a long time, we actually have this successfully done, and we have this thing working inside Huawei. Hopefully, one day we'll get it in the outside world also. But now I'll be describing to you the academic part of this work. So there is some additional perspective of industrial work, which I cannot, unfortunately, describe to you, but for the academic interpretation, I will be happy to answer your questions. So about the business application, as we started from, it's pretty normal when we are writing a code in Python. This is really important that we are talking about Python now. When we write a code in Python, we could run it, and after we run it, we get some exception, and this exception is pretty informative. And it was designed to be informative, actually, for a person who writing the code, or maybe just trying to get along with this code. So the main idea that we could getting the code snippet where the exception has been erased, and the exception text exception description itself, we call it traceback. When we get this traceback and code snippet, this is pretty natural, at least for me, to go for some web search browser, and I just to paste the code snippet and code traceback to the search box, and type enter and search for the results. Like maybe in many cases it would be Stack Overflow, and this like I'm doing my work partially when I'm writing the code, that I'm just go to Stack Overflow, reading what people saying about the problem they have. Maybe this helped me to understand the problem I have. So this is business application, and we decided to actually make it more concrete. So there are several works previously which are just using the web search engines and trying to solve this issue, but we have been using a bit another approach. First of all, how we have stated the problem. We have stated this problem as an information retrieval. Information retrieval problem, when you have some query, in our case, query is code plus traceback. And when you have a document set, the document set, this, for our case, this is answer for Stack Overflow. If we are talking about, for example, some web search, then a query is just natural text, a few words in natural text, and documents are just documents in the internet, obviously including the answers from Stack Overflow, but this is not important for the general web search. So the main idea, how it's going here, we have on right picture. So we have code, this small snippet. Of course, for example, is like a tiny snippet of code and tiny traceback. In the more general case, it's there could be longer, but code and traceback are used as query and answered from Stack Overflow, actually from Q&A form, but in our case it will be Stack Overflow. Used as a document set, and we embed all of them. Hopefully everyone understands what's the mean embed, but in case that there are some people who don't get exact idea, this is some model which read the text and output the vector, and this vector is used in dot product ranking, and after that we just rank the posts and get the answer from the Stack Overflow. So this is our description of our information retrieval task. So what about the data? If we get to this, if we go to the site of Stack Overflow, we can see that in Stack Overflow there are a lot of information. Actually, there are names, there are some specific points like edited or something. We just use text of an answer, and we just use this specific type of mark, which is the green mark to the bottom. In Stack Overflow, it means that this specific answer has been accepted by the person who actually asks the question. So we suppose, this is really important for our tasks, that we suppose that this answer is actually solving the issue has been described in the post. So this is maybe not generally true, but for our means, we using this information as it has been true. So there are Stack Overflow questions, Python related ones. There are actually a lot of such questions, but it's about 2 million question answer pairs there, but mostly questions. And when we filter out the only good questions, there are a few specific requirements from our side, that question has code snippet or at least traceback included in the text, and the answer is accepted. We have only 1 million question answer pairs after the filtration. And the important part is the test set. The test set itself, there are two actual test sets. One is handwritten, and one is 500 full duplicate questions. we have started with handwritten questions, and we found out that they are not good enough in our case, and we switched to these 500 full duplicate questions. Full duplicate is not really obvious term. Let me explain what does it mean full duplicate for us. The main idea here is that we need a question. We need for this question to have a duplicate. That means that some moderator from the Stack Overflow has checked this question and found out that there is another question with this same meaning. This is actually really important because for several reasons. First of all, first reason is that when you have been trying to ask a question on Stack Overflow, maybe you have tried, maybe you have not, but if you are trying to do this, Stack Overflow will definitely propose you several options for the questions, already existing questions. Maybe they already answer your questions. So the main idea here is that Stack Overflow help you to find the already existing question and maybe join it, maybe something, but they hope that the content on their site will be in some way unique. That means that there are not much duplicate questions. But this is also really important that once we are actually working with natural questions, natural language questions, that means that there is always a way to formulate a question which is actually have nothing in common in the means of words with some different question, but it has exactly the same meaning. So this is why there are such things as duplicate questions on Stack Overflow, and moderators actually, if they found these duplicate questions, they just give a link. So we use this link as important source of our questions, the full duplicate questions. And what does it mean full duplicate for us? It means that this linked question has this green mark. So for some reason, maybe this is, I actually have no idea why it's so rare, but there are only 500 full duplicate questions out of 2 million question answer pairs we have in raw data. So this is our test set with 500 full duplicate questions. So a few words about the model, which is not that maybe close to what you already have seen, but still this is the same picture as a few slides before, but now I'm concentrating on the model itself. So as I said before, we have query as a code plus traceback. We have documents which have been embedded, encoded by the model encoder. And as you can see, maybe you have seen this small line, say which with the text parameter sharing, and that means that these two encoders for query and for the documents are the same, essentially the same model. So this is why we actually call our model single encoder retriever Sentry. So we use our Sentry as one model, and this is actually an important point because in our domain, I mean NLP, there are actually a lot of works which are using different encoders for query and for documents. And the thing that we are using one model is kind of unique. Our model, as actually nowadays is pretty common, is based on some pre-trained language model. I'll describe what the language model is in a few slides. but I need to specify this. This is graph called BERT. We actually have tried several pre-trained language models, but this one was the best in our kits. And also, the last point is this esoteric thing, hard negative mining for self-training. I will try to explain these esoteric words to you, but first of all, I need to have a bit, talk a bit about the graph convert. So what is the graph convert itself? We need to first understand what are the input data here. So input data for our meanings, this is source code. As you can see, some simple source code. This source code is parsed into abstract syntactic tree. I hope everyone understand what is this. It is just tree describing the how it could be said, the links between the different entities inside the code. So we use for this, not we, of course, but the authors of GraphCodeBERT, they used the compiler tool to get the AST. We also get the variable sequence in this graph, and we get the variable relations. And these variable relations are simplified AST. We just simplify AST and use part of the information inside this AST. How we use this actually? So we get this AST information, but we need to understand how we actually can use it in GraphCodeBERT. Really good question. If someone hasn't asked me, the idea is like we have source code. We could have comment, for example, return maximum value for this specific code. So what is the idea here? We have source code text, we have natural language text possibly, and as you can see, we have a variable sequence. And this is actually really interesting because these pre-trained language models, it has been shown for several domains, not including this one before, but it has been shown that these structured sequences like time series or this sequence of variable links actually has been could be modeled in a good quality by this language model. So the authors of GraphCodeBERT just proposed that they could use text, code, and variable sequence together to solve the task they want. And task they want is just masking. Actually, language modeling, modern language modeling, is a bit different from classic language modeling. I will not be describing it in detail here. If you want to, I will answer the questions. But modern language modeling used so-called pattern masked language modeling. So masked language modeling, it means that we mask in our sequence several some percentage of the tokens, and tokens in our case are either code, either text, or the variable links. So these are the tokens we have, and GraphCodeBERT is learned to actually predict these missing tokens or links. And this is why it's actually so good. Interestingly, in our case, in our model, we do not use this third link part. We do not use the variable sequence or some additional information from AST. We just use only text, and this is already enough. So we have been returned to this slide with this PLM, and hopefully now you have the idea of PLM we have. Now we go to the hard negative mining for self-training. First of all, we need to understand what is the hard negative. But first, we need to understand negative itself. As I said, we're working with the information retrieval. And in information retrieval, we actually have such idea as positive and negative documents. So we have a query, for example, for this specific sample query is red dresses. And we have 3 documents. It's enough for us to demo, but of course, in practice, there are like a few billions of documents in some search engine. So we have 3 documents: a red dress, black shirt, and blue jeans, maybe trousers, no. So, and we have some model. It's in this example is ListNet. It's really not important for us. We just rank these documents according to the query. So the best document will be on the top. So the main idea here is that we have red dresses query, and of course, a red dress is a good answer to this query. And we could suppose that a red dress is actually the document that has been searched by the user. So this is the document we need to place first. But also we know this is the document. This is the right document. So we call this document positive. And this is when we learn some model for information retrieval, we of course need positives. So we need to know which document is actually answering the question formulated as query to the search engine. This is one part. Another part is of course negatives. Once we have positive, we should have negative, and negative. It is a bit different story, because all the documents inside the document set, except the documents which are positives for specific queries, it's important. For specific query, they are called negatives. And even the positives for some other query, also negatives for this specific query. And of course, most of the data are negatives, and positives are actually scarce. And this is a question of always in the learning of information retrieval models. We need some additional data, and this additional data is so-called hard negatives. Hard negatives is when we have some specific question. For example, if the blue trousers were red trousers, then we could have this hard negative. So main idea that hard negative is resembles the right document, the positive document, but it's still the negative document. So if we have this red dresses query, we have a red dress as positive and red trousers as negative. And this is a really important part. So we could get more information from the hard negatives, because our model need to actually choose between really similar objects, and this will help us to learn, to teach the model, and model to learn the good ranking model inside it. So hopefully now you get the idea of hard negatives and negatives, and now we can have together a good question. Okay, we have negatives. It's obvious. Negatives are everywhere. We can get easily the positives, because we have the we have some data set where we know the positive documents, but where we get the hard negative from? And this is a good question, and I'll try to answer it in the next slide. So this is second part of this esoteric phrase, this self-training. Self-training this is idea actually not have been proposed by us, unfortunately. It's really great. And the idea here is that we have some model which is trained on retrieval data. For example, model is, in our example, it's Sentry, but it could be any other model. We have a Sentry model which is trained on our database of question answer pairs with positives. We know the answers for these questions, and negatives. And as you could get that there is no hard negatives yet. We just train our model with negatives, and that's it. We have trained it, and this is our first iteration model. And we use this first iteration model to actually get some markup on our training data. And after we get the training data markup, we get our hard negatives. So we get our hard negatives from the model we have trained. And after we get the hard negatives, we use them as input for our training of our model for the next iteration. So it's why it's called self-training. We train our model with output of our model, but from the previous iteration. It's the same model, but trained with the worse data. And actually, in the literature, they use several such steps of self-training. But in our case, one step was enough. So we used one-step self-training. So we just trained one model, feed it with the hard negatives, and that was enough for the next step. About the achieved result, our main metric were about the recall top 10, and what we can see here, we can see that BM25 is actually one of the best ideas in information retrieval for at least 50 years. And this is a really simple baseline, which is really hard to beat. And if you ever would have information retrieval task, always start from BM25. It will be good both for you and for the task. So we have beat this BM25 for 5%. In our case, we have achieved recall top 10 together with some additional tweaks, which I will not be describing to you due to obvious reasons. And this has been transferred to this product with the hacks. So our model, which is we call Code Sentry, this Code Sentry achieved as a single model 45% of recall. So this is really a strong baseline. And we actually going to release the collected data, and hopefully you will get the data and understand how it could be useful for you. This is actually finishing our current work I've been talking about, but there are a lot of other stuff I could stop here to answer some questions.
So first, could you please tell a little bit more? I think I might have missed this point about the search by snippet data set. So how exactly did you collect it for the, the Stack Overflow part is, I understand, but how, do you think it would be beneficial to maybe augment it with some other kind of data like codex glue data where we have decent documentation for the code, stuff like that? I understand these are a little bit different, but
thank you for the question. I actually do not you have asked two questions. First question, how we actually get the data. We used publicly available dump of this Stack Overflow. This is one part. Another part about the augmentation. The augmentation is I think would be beneficial, but I don't know about the data you've been saying. I need to check on it. But we've been thinking on augmentation it with GitHub issues. Maybe GitHub issues will be helpful for this specific task. And we actually were thinking to augment and use it to improve the quality of our model. But as it always be, I think we have another task to do, and we cannot do more of this task, unfortunately. So if you am I answering your question?
Yeah. And second, slightly related question.
Mm-hmm.
Did you try, I mean, search by snippet is a wee bit, I mean, a synthetic setup. Did you try, maybe it's coming later, but did you try your model in a more realistic setup? What I'm asking is that basically it feels like a significant part of the answer can leak from the question. Like the example you're showing now is basically providing, well, I mean, in this case, it's not too much, but sometimes it's only a small mistake, which so basically the model can figure a lot from the question, which probably what does not happen in real life unless we're talking about code repair.
Yeah, thank you for your question. This is actually a really good question. And we have been working a lot on this leakage. And this is why the full duplicate questions are so precious, because they have no leakage inside. And we actually, what we have been doing, we've been doing stretching. We've been actually parsing the questions and filtering the code and trace back from the questions. So we search on the clean data. Of course, it could be some leakage, but this leakage will not help us in terms of full duplicate questions because they have no leakage. But for training, as I said, we just cut out the code and the snippet, code snippet and trace back from the questions to actually be able to query them. We use this cutout data as query ones. So we use the cutout data as query and the rest as the documents.
Yeah, I can.
Sorry?
Thank you.
One of the main
Thank you. I got your answer.
Okay. Okay. So thank you for your question. It was really good ones. I have a few slides to actually show you more. We also tried. What I wanted to say is that, in my opinion, our setup is not really synthetic. It is pretty natural. The synthetic is training setup, but the setup of the evaluation is pretty natural.
Yeah, I do agree. It might have been a misnomer in the process.
So about the other things, we also have tried our approach on the existing code search net, which is included in Codex Glue, and we found out that our graph code BERT was the best on the time of this screenshot. Now I think it's been beaten a bit, but we could also improve, and we are working on the next paper where we describe these results. This is like I would say some spoiler a bit of results. We could spoil it. The model is a bit different, but I will be not describing it due to the paper is not released yet. Also, we have been working on code detection, clone detection. As I said, clone detection is a really interesting task. If you know about it, the clone detection has 4 types classically. First type, when we have identical code fragments in different places, we need to just find it. And the type 4, where we have some code snippets which are have nothing in common, but they have the same effect. So they have, for example, same output. And for this, this is the example of such idea. So we have a seriously different code which is doing the same, but it cannot be found easily with standard keyword search. This is standard dataset for this, which is called POJ 104, which is C++ code for Open Judge system. Students are submitting their C++ code to solve some tasks, and as you can see, there are some interesting results there. So we just using metric mean average precision to actually choose the right piece of code to solve the task, but not only solve the task, but we trying to find a piece of code which is actually solving the same task. And here we can see that our approach, this is approach from which is the same as in previous slide, is beating the state of the art by 5%, which is really great. And we will describe it and release the paper in, I think, a few months, hopefully.
Sorry.
Yeah.
Just to clarify. So you trained this, you trained your model on the same, pre-trained the model on the very same Stack Overflow data set, server snippet, and then you fine-tuned it on POJ. Am I right, or did I miss something?
Actually, this is a good question, and I need to go to the next slide, because we actually collected from again from the public dump the data from I forget the exact site. I remember and state to you. So it was public dump of some site with the same idea when we have some problems to solve and people solving them, and we pre-train our model on this data set. It's code forces. Well, yeah. So it's code forces data set, and these code forces they have the same idea. So they have task description and several people who are solving the same idea, the same problem, and some of them are successful, and we need to find the successful attempts. And we pre-trained on this data set and showing good results on this data set. So we have improved, we used pretty the same architecture, not exactly the same, pretty the same architecture for our CCT, and it was trained on this code forces dataset and showed good results. But code force itself, we think this is really interesting, and no one has been done this before. That we can do the colon detection in cross-lingual manner. So there are, for example, Java solutions for some problems. There are some C# solutions for some problems, and there are I don't know C++ solutions for some problems. I don't remember. Maybe they do not have C++ here, but Python, Java, and all this stuff has been presented here, of course, included. And we have solutions in different languages, and we can actually get their semantic even cross-lingually. And this is a good question, how we can do this, and we get the actual cross-lingual data set, and we found out that our model is good enough, and it's really better than PUG trained GraphCodeBERT, which has been used as baseline for us, and BM25, and maybe unfortunately, maybe fortunately, even cannot beat something. It's just showing zeros everywhere. So it's a really hard task for BM25. It's a good task for GraphCodeBERT trained for clone detection. It's about, you see, about 20%. And it's actually our model is quite good in this task. So hopefully we'll release the dataset also someday, and we describe our model. I have actually a few slides about defect detection, text generation, and code translation task we have been working about it, but they are not showing the results we have achieved, because there are no results on open data sets, so I cannot show them. So I'll just skip them. If you have some questions I could answer, but about the conclusion, what I wanted to say by my talk, I wanted to say that NLP nowadays is powerful tool for this PLP or AI4SE, artificial intelligence for software engineering. Of course, not all the tasks in this field could be solved by NLP, but many could be. Classic tools are still very good in many tasks, not in every task, but in many tasks are still very good. So please use BM25. It's a really great approach. And there are a lot of new tasks in this field which can be solved and which could be formulated. And this field is pretty hot, I would say. And this is a good starting point. This is actually it. Unfortunately, this slide is a bit out of date. While I've been preparing my presentation, our hiring is a bit frozen for now, but you could still have a try. Maybe we could manage something out. So please reach me in Telegram or by email if you want to have a chat or something. And that's it from my side. I could answer some additional questions.
Oh, yeah. So first of all, thank you for your talk. And let's, please, folks, raise your hands if you have any questions. So we'll have some kind of a queue.
Yeah.
I'll give like half a minute for people to make up their minds. Yeah. Okay, so while people are still thinking, I would start with a few questions of mine. First, you mentioned the tasks for which you cannot share the progress because you have trained on these private data sets.
Yeah.
So can you please tell me a little bit more on how do you collect these data sets? Like, I'm not sure, what is appropriate and what is not appropriate to tell about that. So please tell me whatever you feel can be shared.
Yeah, I understand. About the text generation, we just collected the data available freely available code, public code, and we parsed the tests from it, which is a pretty tricky task actually. And actually, there are a lot of work done which has been done for Java, and we are concentrating on the Python. So the right picture is about Java, and we take it from the I take it from the paper describing the approach for Java, but approach for Java is not working for Python, at least exactly the same approach. And we need to collect the dataset using somewhat closed methodology, and we are trying to make the model, which is of course language model, to generate tests. As input it has method body and context, and as output is the test for the method. So this is what we are working on right now. Am I answering your question, or maybe not?
Yep, you definitely do. So, well, I mean, I might be missing something. So the reason you're not willing to release this data set as of now, because you have spent a very decent amount of work to collect the data, and basically this is why you want it to be private. Am I getting this correctly?
Actually, there are some. We are thinking. This is actually our joint work with our colleagues from other departments. So we are jointly thinking of maybe we could share some data, but I do not know. I just do not know, and I cannot say if we do release something or we do not. It's an open question for now.
Okay, so why I'm asking this question is actually related to the next question of mine. So let's say you're not releasing this data set. Do you think you would release the model, the trained model, for people to use, maybe like release it at Hugging Face or stuff like that?
I see your question. This is interesting. Interesting question. If we are will get the if we will be agreed to actually do the publication, and even we cannot release the data set, but if we agreed for publication, the data set I think we'll need to release at least in some way. We also could release the model, but releasing the model has requires more effort from our side, unfortunately. So it's more effort in by the means I mean the administrative things to do, like getting approval and so on. It's not that easy piece of cake for us to do this, but we could try. So with more chances we release the data. I would say so.
Okay, I see. Thank you. Right. So, folks, any other questions? Okay, if not, I will carry on. So please, could you switch to the slide for the code duplicate identification? So,
yeah,
in this clone detection, I want maybe not. Not POJ. Maybe your new one.
Okay. Yeah. Okay.
So, how does it work in your data set? So, do I recall correct is that you only focused on type 4 clones, or were there other kind of clones in the, I mean, in the mix? I do understand that. I mean, you did cross-lingual clone detection, but did you also? But maybe not. You also had some intralingual clone detection, because I guess Codeforce's dataset contains some healthy amount of intralingual clones.
I understand what you mean. Actually, these two tables are devoted to, in some way, intralingual cross detection. It's called cross-lingual because we use the same model for all the languages. So we could use the same same model for all the languages and detect there. We actually have some. Sorry, let me finish. We have some additional results on the cross-lingual when we have, for example, ask something in not ask, of course, code snipping in Python and searching, for example, in Java. But I just not included this in the presentation because I decided there are a lot of other stuff to talk about. And hopefully, of course, this will be released as a paper, and the results will be there, all the results, of course.
Okay, so yeah, I guess that I just misinterpreted what you said earlier. All right, so do you have any comments maybe or any kind of data on how does this, like, let's talk maybe MRR 20 Python. So you have 75 for your model. How does this break down for different types of clones? I guess that type 4 clones are the hardest to identify. But the trick is that, I mean, I would find most probably the application for identifying type 4 clones is the most obvious, in the sense that if you have a large industrial code base, you would like to find type 4 clones to figure out whether there are like duplicates of logic in your code. And for what I've studied, like when I interviewed developers, they told me that for a completely unrelated project, they told me that this kind of work duplication is indeed a problem. So can you tell me a bit about type 4 clones? What was the scores for that?
Yeah, this is actually a pretty good question. We haven't done profiling on these typings. Unfortunately, I cannot say anything just because I do not know. So this is actually a really great question, and maybe we could do this analysis of the data set. It would require us some additional work because it's we need to check the other types of the how the types are presented in the data. It's not that easy, and we need to spend a bit more effort on that. I'm sorry, I have time maybe for one more additional question.
All right, folks. Any other questions that we have in the audience? I mean, so far I've been holding the floor. Maybe somebody else would like to have a question. 1, 2, 3. Okay, then I'll finish. So could you please comment on the different scores you have for different languages? And in particular, I might be missing something, but it's not really clear for me. Again, may I understand that, for example, Python is easier than Java because maybe the structure is easier, so it's easier to figure out a clone. But somehow, I mean, let's look at the two tables you presented, and I see that Haskell is very decent at mean average precision at 100, but MRR in 20, it's like compared to some other languages, it's doing not so hot. What could be the reason? Could you please tell me?
This is actually a really good question for me too. There are several not that easy, understandable to me things. For example, why the C# is doing not so great, like comparing to Python or Ruby. Why they are so easy? Why it's in some ways is lower than Java, and in some ways is higher than Java. This is like open questions to me. So this is need to be done. The analysis need to be done here. This is only start of our work. We just tried a few tricks, but we haven't in depth analyzed this.
All right, thank you so much. So, well, as we are out of time, thank you very much, Valentin, for coming to our seminar, and thank you for presenting our work, your work, and thank you, folks, for coming. So I remind you that we are going to have another seminar in a month or so.